Hi everyone, a warm welcome to the topic line integral. Complex definite integrals are called line integrals. They are denoted by integral over c f of z dz. Here the integrand fz is integrated over a curve c or through a portion of c. Really these integrals are complex integrals in terms of real definite integrals. So we can evaluate these types of integrals by converting into real definite integrals. In our problem, C may be straight lines, triangle, square, rectangle, parabola or a part of a parabola, circle or a portion of a circle. Also at times C is given by its parameter representations. This video is based on evaluation along straight line and triangle. So we must know the equation of straight line joining 2 points x1 y1 and x2 y2. And its equation is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1. Let me evaluate few problems. We have to evaluate integral over c, real z dz, where c is the straight line segment joining 0 and 1 plus I. Here we have to evaluate integral over c, real z dz. See, in all these questions, z is always x plus iy. So what is dz? dz is dx plus I dy. So we have integral over c, real z dz. Real z means real part of z. Integral over c. What is the real part of z? Real part of z is x. What is dz? dz is dx plus I dy. See, this is the given integral. Here we have to integrate x into dx plus I dy along the straight line segment. See, you consider a straight line segment joining the points 0 and 1 plus I. See, what is 0? 0, 0 is the ordered pair 0, 0. And 1 plus I is the ordered pair 1, 1. Really, in complex plane, this straight line is, see, it's a straight line joining the points 0. 0 is our origin 0, 0. And 1 plus I, it is 1, 1. See, in the z plane, this is our straight line. See, you have to integrate this function along this straight line. See here, it's not necessary to draw the exact straight line. You just draw a straight line with endpoint 0 and 1 plus I. Here we have to evaluate along the straight line. So first you write the equation of the straight line. So how to write the equation of the straight line? For that, we know equation of straight line joining 2 points x1 y1 and x2 y2 is, what is the equation of straight line joining these 2 points? It is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1. See, this is our result. You consider this point as x1 y1 and it has x2 y2. Now you can easily write the equation of the straight line. So what is the equation of the straight line? It is x minus x1 is 0 by x2 minus x1 equal to y minus y1 by y2 minus 0. That is x by 1 is equal to y by 1. So x equal to y. So equation of the straight line is x equal to y. Here we have to evaluate this integral. Here the difficulty is, see, in the integral you can see there are 2 variables, but we have only single integral. See, in the case of 2 variables, if we have a double integral, we can easily evaluate. Here only single integral. So a single integral can be evaluated with respect to a single variable. So you have to convert these 2 variables in terms of a single variable. See, here the variables are x and y. So you have to convert y in terms of x or x in terms of y. Anyway, you have to convert into a single variable either in x or in y. If it is in x, you apply the limit for x. If it is in y, you apply the limit for y. So you can evaluate this integral in two ways, either by integrating with respect to x or by with respect to y. See, you can convert into a single variable with the help of the given curve. See, we have to evaluate this along the curve C. What is C? C is really x equal to y. See, on C, x is y. Here, really this question is so simple because converting to x or y both are same because equation of the given curve is x equal to y. Here, x is y or y is x. So, we can replace x by y. So, you put x equal to y. When x is y, see on the curve x equal to y. So, what is dx? It is dy. If you replace x in terms of y, you have to replace dx. What is dx? It is dy. Plus I into dy is dy itself. Here, the integral is converted into a single variable. Now, you can easily integrate with respect to y. For that, you have to give the limits for y. What is the limit for y? See here, y varies from 0 to 1. So, it is integral 0 to 1 y dy plus I into y dy. That is equal to, it is integral y dy, it is y square by 2 plus I into y square by 2 from 0 to 1. That is 1 by 2 plus 1 by 2 minus lower limit is 0. So, it is, so the answer is 1. Again, you can convert this integral in terms of x. That method is, if you convert in terms of x, you have to replace y. Only here you can see y. What is dy? Dy is dx. So, you put dy as dx. Now, put the limits for x. Here, the both limits for x and y are 0 and 1. X varies from 0 to 1. So, either this integral is integral 0 to 1 y into dy plus I dy or this integral. Both are same. You integrate it. So, here integral 0 to 1 x dx plus I x dx, that is x square by 2 plus I x square by 2 from 0 to 1. You apply the limits, you can see it is 1 by 2 plus I by 2 minus 0 plus 0. It is 1 plus I by. See here I noticed a small mistake. When you put the upper limit 1, first term is 1 by 2. Next term is I into 1 by 2. So here it is I. So the answer is down to 1, it is 1 plus. Anyway, both answers must be unique. Here we had a small mistake. Now we corrected it and the answer is 1 plus I by 2. Next we have to evaluate integral over C, imaginary of z square dz, where C is the triangle with the vertices 0, 1, I in counterclockwise direction. See here we have to evaluate integral over C, imaginary of z square dz. See, imaginary of z square means it is imaginary part of z square. What is the imaginary part of z square? See, in the previous question, it is a real part of z. Here, imaginary part of z square. So, you should be very careful whether it is z or z square. See, it is z square. We have z equal to x plus iy. Always dz is dx plus I dy. Here, we have to find the imaginary part of z square. So, what is z square? It is x plus iy the whole square. That is x square minus y square plus I into 2xy. You expand by using a plus b the whole square. So, what is the real part of z square? Real part of z square is x square minus y square. What is imaginary part of z square? That is the coefficient of I. It is 2xy. See, in z equal to x plus iy, what is the real part of z? It is x. What is imaginary part of z? It is y. Some students may write imaginary part of z as I into y, which is wrong. So you always keep in your mind, imaginary part is coefficient of I. See, So see, here we have to find imaginary part of z square. So first you write what is z square. Then you take its imaginary part. Its imaginary part is coefficient of I, which is 2xy. So imaginary part of z square is 2xy. So here, integral over c, 2xy. What is dz? Dz is dx plus I dy. We have to evaluate along c. What is c? C is the triangle with vertices 0, 1, I. Next, we have to mark the triangle with the complex plane. So, our complex plane is vertices of the triangle are given by 0, 1, I. So, 0 is the point 0, 0. See, in complex plane, any complex number x plus iy can be expressed as ordered pair xy. So 0 can be marked by 0, 0. 0 is our origin. See, this is our point 0. Then what about I? I is, it is 1 plus I0. It is 1, 0. 1, 0. You mark it as 1, 0. Next I. I is 0 plus I into 1. That is 0, 1. So I is the point 0, 1. So our triangle is this triangle. See, C is the triangle with vertices 0, 1, I in counterclockwise direction. See, counterclockwise direction is anti-clockwise direction. See, in complex analysis, anti-clockwise direction is considered as positive direction. So our direction is always in the anti-clockwise direction. So don't confuse with its direction. And usually direction will not be given. We take it as positive direction and it is an anti-clockwise direction. Here it's mentioned. So our direction is this one. So here we have to integrate imaginary part of z square along C. C is this triangle. See, a triangle is the combination of three straight lines. See, from the first question we noticed how to evaluate along a straight line. So here you can apply that. Since C is the combination of three straight lines, so you can split the integral. For convenience, you consider this point as O, A, B. So our triangle C is the straight line joining OA and OA, AB and BO. So integral over C is integral over OA plus integral along AB plus integral along BO. 2xy dx plus I dy, 2xy into dx plus I dy, 2xy into dx plus I dy. Now the given integral is split into three integrals. Let it be I1, I2 and I3. Next we have to evaluate I1, I2, I3 separately. Next, evaluation of I1. See, I1 is integral OA 2x, so you can take 2 outside since it is a constant, dx plus I dy. Here what is OA? Can you write the equation of OA? OA is a straight line. Here you have to remember one more thing. See, we know the equation of straight line joining 2 points x1, y1 and x2, y2. If you find the equation of OA by using that equation, you can see one of the denominator will be 0. That is, you can't find the equation by using that formula. Here, you have to identify the equation of the straight line OA. See, OA is the part of the x-axis. What is the equation of x-axis? It is y equal to 0. So, equation of OA is y equal to 0. So, another shortcut method for finding the equation of OA is, see here, y component is constant. See, along OA, y is always 0. Is y equal to 0? So, equation of OA is y equal to 0. Then, how to write the equation of AB? AB is a straight line joining 2 points 1, 0 and 0, 1. What is the equation? You consider it as, see, it's a straight line joining 1, 0 and 0, 1. So we have to write this equation only while evaluating I2. So next we have to evaluate I1. See, OA is y equal to 0. So 2 times when y is 0, when you have to put y equal to 0, then this integral will be 0. So what is its integral? Integral is 0. So I1 is 0. So we have I1 equal to 0. Finally, we have to substitute these values in equation number 1. So you have to remember I1 is 0. Next, we have to find I2. See, I2 is integral AB 2 into xy into dx plus I dy. What is the equation of AB? This is a straight line joining 2 points x1, y1 and x2, y2. You consider it as x1, y1 and x2, y2. So its equation is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1. Right? Yes. That is x minus 1 by minus 1 equal to y by 1. That is x minus 1 equal to minus y. Or what is x? X is 1 minus y. See, or you can write the equation of the straight line as x plus y equal to 1. We are familiar with x plus y equal to 1. Really, AB is x plus y is equal to 1. See, x plus y equal to 1 can be written as x equal to 1 minus y or y equal to 1 minus x. So, anyway, equation of AB is x plus y equal to 1. You write this equation. Here, for integration, you have to convert into a single variable either in terms of x or in terms of y. Here, what is y? Y is 1 minus x. Y is 1 minus x. I wish to express completely in terms of x. So, we have to replace y. So, 2 into, so I am replacing y. You can also replace x, then completely in terms of y. Anyway, both answers will be unique. So here I am replacing y. What is y? It is 1 minus x. Dx plus, what is dy? Since y is 1 minus x, dy is minus dx. So here, minus I dx. Next, in terms of a single variable, and you put its limits. Here, x varies from where to where? It is 1 to 0. Not 0 to 1, it is 1 to 0. If you replace completely in terms of y, then you put the limit for y. What is the limit for y? Here limit for y is 0 to 1. From here we have to put for x. Here you can take a dx common outside, that is 1 to 0. I open this bracket, x minus x square into 1 minus I into dx. See here, 1 minus I is a constant. You take it outside. 2 into 1 minus I. 2 into 1 minus I. Integral 1 to 0 x minus x square dx. That is 2 into 1 minus I into x square by 2 minus x cube by 3 from 1 to 0. That is 2 into 1 minus I. You put x equal to 0. Both upper limits are 0. Minus lower limit 1 by 2 minus 1 by 3. So it is, you simplify this, you can see this, and this is 2 into 1 minus I into, it is 1 by 3 minus 1 by 2. 2 into 1 minus I into 6 LCM 2, that is minus 1. 3, that is I minus 1 by 3. So we have I2 is I minus 1 by 3. Next we have to evaluate I3. I3 is integral BO 2 into xy dx plus I dy. So what is the equation of BO? BO is 0, 1, 0, 0. Here x is always 0. See, along BO, x is always 0. So, equation of BO is x equal to 0. So, on BO, x equal to 0. Or you can consider it as the y-axis. On the y-axis, x is 0. So, this is 2 times integral. You put x equal to 0. When x is 0, this term completely 0. So, the answer is 0. So, we have I3 0. You put these values in equation number 1. So, this equal to 0 plus I minus 1 by 3 plus 0. That is I minus 1 by 3. So, value of integral over C imaginary z square dz is I minus 1 by